Welcome to Lesson 7, where we will discuss the properties of sound. Sound is a disturbance of mechanical energy that propagates through matter as a wave. Because sound waves must move through matter, they cannot travel in a vacuum. Most often we think of sound as traveling through air, but sound actually travels more readily through elastic solids and liquids. The measurable properties of sound include frequency, wavelength, period, amplitude, and speed. Humans perceive sound by the sense of hearing. By sound, we commonly mean the vibrations that travel through air and are audible to people. However, scientists and engineers use a wider definition of sound that includes low and high frequency vibrations in the air that cannot be heard by humans, and vibrations that travel through all forms of matter, gases, liquids, solids, and plasmas. Air, like all gases, is a poor conductor of sound. Three things are necessary for the transmission and reception of sound: the source, or something which generates the sound waves, such as our voice box, a speaker, or a running automobile engine; a medium, for the sound waves to travel through, such as the air or water; and something to detect the sound, such as our ears or a tape recorder. Sound travels in waves. A wavelength is the distance from the crest of one wave to the crest of another. The progress of any wave involves two distinct motions. First, the wave moves forward at a constant speed, and the particles of the medium that convey the wave vibrate harmonically, for example, the piston in a reciprocating engine. If we were to drop a pebble into a pond, the waves would begin to radiate outward from where the pebble struck the water. At the same time, the waves are vibrating vertically between the wave crest and the wave trough. The period of a vibrating particle is the time in seconds required for the particle to complete one wave cycle. The frequency is the number of vibrations completed in 1 second. The period and frequency are the inverse of each other. As the period increases, the frequency decreases, and as the frequency increases, the period decreases. The velocity of a wavelength is equal to the wavelength divided by the period, or multiplied by the frequency. The amplitude of vibration is the maximum displacement of the particle from its equilibrium position. A sound wave can be reflected much like a light wave, what we might think of as echoes. When a sound wave reflects off of a surface, the angle at which it strikes the surface is equal to the angle at which it leaves the surface. The speed of sound describes how much distance a wave travels in a given amount of time. The speed varies with the medium employed. For example, sound waves move faster through water than through air, as well as with other properties of the medium, especially temperature. The term is commonly used to refer to specifically the speed of sound in air. At sea level, at a temperature of 21 degrees centigrade or 70 degrees Fahrenheit, and under normal atmospheric conditions, the speed of sound is 769 miles per hour. The two basic physical properties of the medium through which sound travels, which govern the speed of sound, are density and elasticity. As a general rule, the more dense or elastic a medium, the faster sound will travel through it. The Mach number is the ratio of the speed of an aircraft to the speed of sound. An aircraft traveling at Mach 0.90 will be traveling at 769 miles per hour times 0.9, or 684 miles per hour at sea level under standard conditions. Note that the speed of sound is not a constant like the speed of light. It changes as the atmospheric temperature and density changes. Temperature is a condition that affects the speed of sound. Heat, like sound, is a form of kinetic energy. Molecules at higher temperatures have more energy, thus they can vibrate faster. Since the molecules vibrate faster, sound waves can travel more quickly. The speed of sound is also affected by other factors such as humidity and air pressure. A decibel is the basic unit for measuring sound intensity. 1 decibel is the smallest change in sound intensity the normal human ear can detect. An increase of sound intensity of 1 decibel is an increase of a factor of 10. 2 decibels have 10 times the sound intensity of 1 decibel. 180 decibels is considered the lethal sound level. The resonant frequency is the frequency at which a body vibrates most easily. Vibration at an aircraft part's resonance can cause its destruction. Aircraft design engineers must be aware of the resonant frequencies of the various components and systems to avoid conditions that cause them to vibrate at resonance. Oftentimes, aircraft are not allowed to be operated continuously within certain power ranges to avoid resonance vibrations.